The hamlet became a museum in 1960, and the shaft that goes through the water wheel predates that, so we don't know when this shaft was changed last. And subsequently, while it's been a museum, it's rotted from the ends. Wood always rots in from the ends predominantly, and the ends of a water wheel shaft are the load-bearing aspect, so you can't allow your wheel to remain rotted at the ends. This end's had 3 repairs during its life as a museum piece. The other end's had 2 repairs. And the way they've been repaired in the past, there's a big cast iron gudgeon on the end, which is a big ring that goes around the tree trunk, and then it has a crucifix cast in the middle, and then the journal comes off that and is supported on a block of oak on these 3 pads, and then a bearing shoe with a brass ring in it. That's become loose on 3 occasions on this end, so they've had iron bars drilled through to find good wood and plates on the end, and then they've injected resin bonding, which is like araldite. It's a strong glue, but because so much is needed, they bulk that up with aggregate sandy sort of stuff, and that's been done on 2 occasions just with iron bars. And then the 3rd attempt, there's some big metal plates outside on the floor. These were inserted in 4 places on the outside of the shaft, and they came all the way through to here, and then there were 2 bands of steel wrapped around those and all welded together and then resin bonded, which you'd think would last forever, but no. So 8 years ago that became loose as well, so we stopped using it as a working water wheel, and we've been sort of saving up and looking for funding since, but we've got funding now. Drilling the resin bond repair out and removing these plates has taken most of the summer, which is far longer than I thought it was going to be. Because there's different materials in there, you're drilling resin bond, then you'll find a bit of metal, there's steel reinforcing in there, then you find wood. So you start off with drilling resin bond with diamond core drills that end up looking like that. When you come across metal that wears these away much quicker, you carry on drilling it, but then when you hit wood, it just gets hot and you make steam, and these don't cut wood. So once you get through to wood, you start with an arbor bit, and then because we're tight-fisted Yorkshire people, we start sharpening and carrying on, and they go from that to that and end up like that. And then when they get to that, they're really quite hard to drill with, so you start again with one of those. So we've gone through dozens of these through the summer, drilling that out. Cast iron gudgeon itself, it's getting on for half a ton. So once we'd wrecked out sort of 2/3 of it, we got the steel work through. Because the weight of the entire assembly is 11.5 tons, and it was all on those ends, we put iron beams through beneath 4 spokes and then packed up off that. We took a lift with a hydraulic jack underneath the gudgeon, propped everything, and then put it all back down, so then the shaft was free floating so we could work on it. Prior to supporting the whole wheel and the assembly on 4 spokes, we had to change some spokes, because that's an old spoke, but that's a fairly good one. That's the sort of spokes that were in the position that we needed to use. Because the clasp arm inside needs to be in a horizontal position, we had to use these specific 4 spokes, and that's what the ends were like. So we fitted 3 new spokes, this pair and the one at the back. The one at the front here was replaced when they did the last resin bond repair in 2005, so we've trusted that one and it's managed to hold it so far. So we changed 3 spokes. That's the gudgeon in place with the resin bonding, and as you can see, once we'd got sort of a day's worth of drilling in, we found the big plates that we knew were there, but when you hit one, your drill stops. You have to start moving to a different position. So that one's off now, and it'll be refitted to a new tree trunk. The tree trunk that's been fitted prior to 1960, seemingly they couldn't find a tree big enough to make the octagonal size that was needed, so it's been planked with 2.5–3 inch planks, nailed in with 9-inch iron nails to make it up to the right section.
So originally would it have just been the tree?
Just the tree octagonalised, which is what we've got. We're putting one back in that's a full size. To hold that tree trunk in that cast iron octagon, you leave a gap, and then you put in what they call folding wedges. So you leave a space that's just slightly less than that, and then you drive 2 wedges together. So from a modern engineering perspective, this all seems a bit wishy-washy, because my training would be keyways and Morse tape, petite keys and things. So I was quite a bit wary about this, but having used this in several instances on other applications of shepherd wheels, once you've driven very dry oak wedges together, and then you've used them in a water wheel environment so they swell up with the moisture contact, they don't come back out. They really, it's a very good way of wedging something, and it's infinitely adjustable. We'll put packings in 4 places and then wedge in 4 more places, and then we'll take the packings out and put more packings in, but you can adjust and centralise from the outside of the shroud to the centre line of the shaft so that it runs true, so we're balanced.
Is it an oak tree then?
It will be. It's an oak tree. We've got 2 trees cut because there's this water wheel to do, and there's a water wheel just beyond that wall that runs a grinding hole. So we've got 2 oak trees, both over 300 years old. They've come from an ethically forested and felled trees on the estate in Reading in Berkshire. I think it's Ensley Estates. They've come from Whipple tree hardwoods, and Forestry Commission's been involved, and they've sourced us 2 trees of a significant size and large enough to make octagonal shafts out of. They're sort of 5 metres long by 785 millimetres across flat, so it's a bigger tree than that because you've got to take all the green wood off on the side. So that's how we've got the ends off, and the shaft is now loose in this hub and this hub. Goes through the wall, and then it goes into a big gear wheel which drives the mechanisms. It's loose in that gear wheel as well. So if we walk out this way and into the tilt shop.
When do you think it'll be running again then?
Hopefully next April when the site reopens after the winter.
Oh, long then, isn't it?
That's pretty
Surprisingly close to the bottom of the wheel pin.
Right. So what did you do? Like a machine? Right. Oh, I see.
Hammers, tilt hammers on the pegs, steel to make blades.
We've got 4 water wheels on side. This is the tilt wheel. Also on this side of the side there's a small, narrow water wheel just through that gap there. That runs this shaft, which runs 2 bellows, and that would blow air into the hearts behind you. So they bring the steel from the crucible made into billets, warm it through again in these hearts before forging them in this room using the big wheel. In these stands here, you have 2 hammer shafts. They're currently under this floor, laid down flat so we can put this floor in. And the back of the hammer gets tilted by these bosses on that big long tilt shaft. So each time one of those dogs goes past, it flips the hammer up. Run the water wheel at whatever speed you need to get the beats per minute on the thing, on the hammer. So there's 2 anvils. There's an anvil here and an anvil there, and 2 hammers.
How many hammers then?
3 of us lifted 1 out onto the floor. There's 1 outside on the floor. It's a piece of tree trunk. There's an iron ring in the middle that have 2 pegs on that get wedged in there.
Yeah.
That form the pivot point, the fulcrum. It has a metal ring at the back with a panel in that gets tilted, and at the front there's another ring round it that forms a hammerhead. So it's a piece of wood with 3 iron rings on it, and the iron rings are wedged on as well. There's one just outside the door. The floor level inside, if you've not been to Abbeydale before, you come down another 2 steps, then there's an iron floor so that the floor doesn't wear away with heavy movement of steel in and out. There's a pit just here, and then the floor level rises up. So to get a 3.1 tonne shaft out and through here on floor levels that were all over the place was going to be impossible. The building's 1785, although it had a new roof in 1960. They're not ancient beams, but we don't lift off the building. So we're going to lift with the steelwork that we've got outside. That's at the balance point. So when we lifted it last week, you could just move this end up and down with 2 of us. And we'll put rollers underneath at metre intervals. This scaffolding floor has been designed to take 3.1 tonnes spread over 5 metres at metre intervals. So we'll roll it out until it gets to the wall, and then you can put your rollers at angles and move it. We'll probably have to do a 3-point turn on rollers. And if we get one end just past that lintel, we can then get a truck with an eye out that will lift the end and just roll it out into the other side. Simple, isn't it? It's been in the planning for quite a long time, this, and Tuesday next week we're hoping to do it. We'll try on Monday, we'll try and finish getting that off, because that's another half a ton in way. So if we get that off, now we've got the floor level right, we can just roll that into a corner. Whereas before that, it's 3 foot down from here, in between 2 big pieces of stone that support it, another big piece of wood with a bearing on. The spur gear inside, it's got an iron ring with double holes. That's one of the old teeth. So there's a pair of those, make 1 tooth on the periphery. In 2005, when they did the resin molding repairs, they bought a full set of teeth. Didn't get round to fitting them, and then shaft failed again, so we've got a full set of teeth to fit. It's got an iron ring, I think it's 1.8 tonnes in total that. It's not held up by the bits of string, by the way, that's just for our confidence so it doesn't fall this way. Below those clasp arms that you can just see at floor level, with some more bits of steel work going through into the pit behind and onto the stonework in front. So it's supported from below its centre of gravity, so that's why we've tied it back, so it can't fall over.
And will your floor level be back to your iron ring?
Yeah, once this shaft's out and the other shaft back in, this floor will go over. We've got this for 6 weeks. So I've got to get one out, fit 2 gudgeons and one back in 6 weeks, otherwise it starts costing us 150 quid a week to keep it. So it's a bit time critical. I'm from an engineering background, but not specifically water wheels and wooden wedges, but we've a millwright consultant from Devon who'll come up for a couple of days with us when we're wedging the first gudgeon back onto a new shaft. Make sure we're doing it right, and then we'll carry on from there. Are there any questions?
Is that shaft sound then?
That shaft's being repaired from that end. If you see the big chunky planking that's gone onto that's a repair from 1960 when they rebuilt the building. The first job after the building was repairing that end. In 1960, when they came on site, this shaft was in and intact, but all the spokes on the wheel outside had collapsed and it had all fallen into the pit. So in 1960 there was a wheel up restoration, but they rebuilt it around the existing shaft. So 40 years later, we're now replacing the shaft in the wheel that they rebuilt in 1940. The back shaft will turn, but we don't tilt the hammer, we leave them laid up. This shear along the way, so that's for nipping. Once you've forged out to the length of the crown size, there might be half a billet left, so you chop that up and then you forge the other. So that's a shear.
Is the spur a later addition because the spur gear, with it being the cast?
You'd have an iron gear and then one with wooden teeth, so one sacrificial.
Yeah, but that tooth that gear, the spur gear there is all steel.
Yeah.
Yeah. So was that a later fitting?
No, it would be at the same time. You've got the technology for casting when this was all put in, but because of the hammering nature, you need something to take out that.
Yeah, the wood does it.
Yeah.
But I'm saying just they use wood for that, but they couldn't do a gear that size in segments.
No, probably not. And they tend to mate up wooden teeth with metal teeth.
Yeah.
And then rather than wearing that, you can change it a tooth at a time and it's easy. Whereas to change a ring because one of them's worn out is expensive. So you'd have a sacrificial tooth. Yeah. And there's an odd number of teeth. So the same tooth, or you'd have 4. If that was an even number, that was an even number. You'd always match up. So you have a hunter tooth on, so that they're constantly changing partners on the wheel.
To the right,
Yeah. Every tooth will get a turn with every tooth on there over a certain number of rotations.
So kind of if you have an odd release and you wear that to
If you get one tooth on there that's eating wooden teeth, it'll take a little bit out of them all instead of killing 14. So that's the tilt wheel and its shaft. Everything I've told you that we've done and we're going to do on this then needs doing on the grinding hole wheel as well. So this is this summer and this winter, and then next summer and next winter we'll be doing all the same thing again for the grinding hole. So if we go back out that way, everybody's in the same boat.
Yeah.
If you want to all come in and then all go to the far end. Viewing area, you can't actually get to see the wheel, it's so remote, but you can see it from where you move into the tilt area. It's a similar style of wheel, it's got wooden spokes and an iron shroud and iron hubs. It's slightly bigger, but there's more wood.
Oh, sorry, Eddie, are you in the middle of the group?
Yeah, I'll be about 5 minutes. Show them damn Tom while you're there.
No, we've been to them.
Oh, alright, no problem.
If you'd like to just come out,
The problems with this is, on the tilt wheel, for the actual trough that it runs in, there's two sides. So we've got big stone ashlar walls to rest the steelwork on. This one's built up against a wall. So we've got ashlar on one side to rest the steelwork, but on the other side we're going to have to build an iron goalpost underneath to even rest it on, and then build an A-frame on that, so it all becomes a bit more precarious. Also, for the route it's got to take, it's sort of 2 rooms that way, through 2 walls. There's a gear wheel, like the one that you've seen through there, but it's got a bevel on it. It drives at 45 degrees onto another one down there. So it's a complete cast iron sectional spur wheel. So it's much heavier, but we're not going to change all the teeth, so there's pluses and minuses. Yeah. But as regards threading the shaft out, it can't go outwards because there's the dam. We're not going to put it in the dam. It drives those sets of gears there which drive a big line shaft. So there's 1, 2, 3, 4 big drums on a line shaft that would drive 8 grinding horses. That drum and this belt bit is suspiciously huge. Far bigger than it needs to be to run belts, so we think this is intentionally big to facilitate bringing the shaft down. It's not quite in line, it'll have to come across, but we can bring it through here on another floor on rollers into this pit. Again, we've got 1960 beams on an 1870 building, so we'll build an iron horse in here so we can lift it up and onto this newly laid floor, sort of concrete floor that's a modern floor, and then again roller it out the door. All the same things we've got to do, removing gudgeons, replacing gudgeons onto the new shaft. Both shafts are going to turn up to site at the same time probably this year, so the shaft for this wheel will get stored along there. The sawmill are going to cut us the cruciform in the end of the shaft for the tilt wheel, because we're going to immediately fit a gudgeon on it and wedge it all up. They're reluctant to cut us the slot in this one because we're not going to use it well next summer and it'll propagate cracks down the shaft, so we're going to have to cut the cruciform in the end of that shaft. Not quite sure how we're going to do that yet, but
chainsaws.
Well, yeah, but it'll not be as accurate as the one they're going to do on a big bench saw. So this again, significant difficulties compared with the tilt that we're practicing on.
Will that belt wheel have to come out?
Yeah,
yeah.
Will.
So that means the whole shaft's got to come out then?
There's couplings in it. There's a couple in there, and the end of the shaft's not much further on. So we'll look to take the shaft out of it, and then this belt bit is filled with a lot of debris at the minute, and sort of tapers up to 2 foot deep there. So we'll roll it up here, and then we might have to get some extra people and lift it out. Then we'll excavate this, and I'm presuming it's flat bottomed, and we'll be able to roll that in there. We've not tried yet. I don't sound as confident on this one, do I?
Presuming a lot of things.
Yeah. It all sort of bears and makes sense. Once we've got shafts in the tilt wheel, there's lots of timbers on the tilt wheel itself. The sole boards are pretty rotten, some bucket fronts are rotten. So once we've got that little free wheel, we can move it round by hand. Once you've got a wheel, we know for a shepherd wheel, once you've got it with a new shaft and wedged and in balance, one man can just walk it round on buckets, and we can get to work on a bucket at a time and replace a lot of timber. Timber-wise, on the grinding hull wheel, it's in a lot better nick. A lot of wood was replaced in 2005, and it's not run as a water wheel much since. So that's next one. Have any questions about what I've told you so far?
Going to be busy.
We are going to be busy, yeah. They keep giving us other projects in and amongst this as well. I'm having to say no.
So do you intend to get the grinding wheels running here?
We'll run the whole line shaft, and we'll probably belt up 2 horses at that end with the biggest wheels we've still got. There's a 5-foot wheel against the wall there, which is a brand new, as big as a grinding wheel would be in here. If you've been on Tom's tour, you've seen the big long crown scythe. These are small sort of jobbing wheels that were fitted because we had a grinder in here through the 70s and 80s grinding small things, but that's the size of a crown scythe grinding wheel. So if we can get 2 of those belted up at that end of the room, we'll extend this viewing gallery to here so you can see the wheel and the wheel pit, the gear pit.
Where do the stones come from?
They were dug out of Stanage Edge and sort of Derbyshire stone.
Yeah.
If you walk on Stanage Edge and look at the bottom, there's ones that have been cut out and then they've found a crack, so they've just left it there. So they're locally sourced, which what made Sheffield unique, which is why you get the factory environment. You don't make steel and then do the process somewhere else, you do it all here.
Okay. Yep.